The James Webb Space Telescope wasn't supposed to be one of the most expensive scientific projects in history. The estimated price in 2000 was just $1 billion. But the complexity of the telescope caught NASA by surprise. It got so expensive, Congress nearly scrapped the project. By the time the telescope launched at the end of 2021, the cost was more than $10 billion. So why did NASA spend so much public money on the project, and why has it taken so long?
Decollage liftoff from a tropical rainforest to the edge of time itself.
The answers lie in the origins of the stars.
James Webb begins a voyage back to the birth of the universe.
On December 25th, 2021, the James Webb blasted into deep space orbit. The destination, a point in space called Lagrange Point 2, 1 million miles from Earth. That's further than any astronaut has traveled, and it's also the perfect spot to investigate the birth of the universe. Light from the first stars began to travel outwards soon after the Big Bang, and that light cooled from visible light to infrared light over billions of years. That's why the James Webb was designed to collect light in the infrared spectrum.
The James Webb Space Telescope is designed to look at our entire history from the first objects that grew after the Big Bang to things right here in the solar system that formed along with the Earth.
The Webb is massive, so it was folded up in order to fit atop the Ariane 5 rocket before launch, and then unfolded in space after it's separated. NASA's scientists dubbed the million-mile trip 30 Days of Terror, because everything had to go right with no less than 344 possible points of failure. One tiny flaw, and the Webb could have ended up a piece of space junk.
This is one of those things where if you're spending the public's money, you're not going to take a chance of, well, why don't you push a button and see if it's okay?
The mission was a success, but 20 years ago, no one ever imagined it would take so long or cost so much to get it to the launch pad. Part of the struggle has been a need for perfection.
We just have to build it and test it and build it and test it and build it and test it until we're satisfied.
NASA couldn't afford to repeat the mistakes made on the Webb's predecessor, the Hubble telescope. After its launch in 1990, the first images came back blurry.
The conclusion we've come to from that is that there's a significant spherical aberration appears to be present in the optics.
So astronauts had to fix Hubble's mirror while it was in space. NASA had already spent $2 billion on Hubble at that point. The repair cost $86 million versus just $2 million had NASA caught it while the Hubble was still on Earth. That taught NASA an expensive lesson. So with Webb, they had to get everything right the first time.
Because it's just so complicated and it's so huge. And so that was the part that I think scared all of us the most, and we gave it an awful lot of attention.
In 2000, the budget was $1 billion. But by 2005, the budget quadrupled to $4.5 billion. By 2010, the year it was supposed to launch, none of the main instruments or mirrors were delivered to NASA. The estimated budget in 2010 was already up to $6.5 billion.
Up until 2011, there were a lot of issues concerning oversight, communication, leadership, management, cost estimating, over-optimism, just almost everything you could think of that could happen was happening.
Members of Congress even considered scrapping the project.
Some have argued that we should cut our losses and move on. Others have suggested that we're rewarding bad behavior by continuing to invest in the mission.
Instead, in 2011, Congress decided to cap the budget at $8 billion and tapped Christina Chaplin to audit the project every year. But nothing could really stop prices from rising, because nearly every part of the telescope had to be invented along the way.
Especially toward the end, they thought, hey, the contractor workforce can decrease and we'll have money to pay for other things that we need to pay. But the workforce stayed high because they had so many technical issues that they were dealing with.
Though it's often compared to Hubble, the James Webb has a mirror 6 times the size of its predecessor and requires far more advanced technology and specialized conditions to operate. It's bigger and needs some of the coldest temperatures in the known universe.
Those two things together meant this was going to be a really, really hard problem, and some of us thought it was really insane at the beginning, honestly. But yeah, very tough, very tough. Those two conspired to make a really hard problem.
And the Webb needs extreme cold for its infrared cameras to operate. -388 degrees Fahrenheit cold, to be precise. To protect these sensitive instruments from the heat of the sun, NASA built a 5-layer tennis court-sized sun shield. Think of the most advanced and complicated beach umbrella you can imagine. It can withstand extreme temperature swings and even small meteoroids that might pierce the thin membrane.
The temperatures we operate the cold side of Webb at are way beyond anybody's ordinary everyday experience, and materials just get really weird at those temperatures. It's a hard engineering problem.
But even that isn't cold enough for one of the cameras, which needs something called a cryocooler to bring the temperature down to negative 447 degrees. NASA spent more than a decade and $150 million developing the cooler. It was only supposed to cost $22 million. In 2018, Congress had to raise the spending limit set in 2011. By the time the telescope was ready for launch in 2021, it had already cost $8.8 billion, making it one of the most expensive scientific projects in history. But there was one more challenge: transporting it from California to a European spaceport in French Guiana in South America. Details had to be kept secret because the valuable cargo would make a lucrative target for pirates. It traveled 16 days from California through the Panama Canal to the launch site. The European Space Agency paid for and oversaw the launch, as well as building 2 of Webb's instruments. Together, the European and Canadian space agencies contributed another $1 billion beyond NASA's $8.8 billion. And that brings us close to our $10 billion total. But all of this just gets us to the moment when the James Webb begins to do science. Some hope to learn more about the origins of the universe, while others, like Heidi Hammel, expect to point it at our own solar system to learn more about some of Earth's closest neighbors.
We haven't had a mission to Uranus and Neptune, and we have developed very sophisticated space and ground-based telescopes, but none of them have the sensitivity that the James Webb Space Telescope will have.
NASA built a telescope to run for 10 years, but extra fuel left over from a near-perfect launch is likely to double its lifespan. NASA will spend over $850 million to run the Webb for the next 5 years. The extra life it may have would, of course, require more money.
At the beginning, it was just me and one project manager and a few people that we talked to, and it's grown to having needed 10,000 people.
Go Webb!
So far, the Webb has little to show beyond this selfie of its big mirror. But it's the images it will record from cameras pointing in the other direction and send back to Earth in mid-2022 that everyone is waiting for. It's hoped that capturing a glimpse of the birth of our universe will make all the time and expense worthwhile. Hubble's images led to 19,000 scientific papers, many of which changed our ideas of the universe. Just one of those revealed the discovery of water on Jupiter's smallest moon, called Europa. James Webb has some big footsteps to follow.
And that's a really powerful aspect of this telescope, Webb and Hubble, that allows these telescopes to continue to produce incredible science year after year after year, even after the telescopes are gone.